Let's look at warm-up problems. It says a small car with a mass of 725 kilograms is moving at 115 kilometers per hour towards the east. What is the magnitude and direction of the momentum? So I guess the hardest part of this problem is just to convert kilometers per hour into meters per second. So let's do that first. Let's take, because we know we're going to have to get into meters per second since that's the unit of momentum. So let me just set this up. I'm sorry, let me go backwards. We want to find momentum of this car. So the momentum is mass times velocity. Well, we know what the mass is, and we know what the velocity is, but the velocity is in weird units. So let's change the units from 115 kilometers per hour into meters per second. And here's how I'm going to do that. I'm going to take the kilometers, I'm going to convert that first. So there is, for every 1 kilometer, there is 1,000 meters. Okay, so that'll get rid of our kilometers. Now I'm going to take hours and I'm going to change them into seconds. So for every 1 hour, I just know this, it's that many seconds. So overall, this is going to be 31.944 meters per second. Wunderbar. So we use that, and now we plug this into the formula back here because we know what the mass is. The mass is 725. So it's 725 kilograms times this meters per second, and we're going to get, that's 31.944 meters per second, and we're going to get 23200 kilograms meters per second. Fantastic. And it's to the east, to the east, to the east. Yeah. Great. Now B says a Hummer with a mass of 2,175 kilograms is moving with the same momentum. What is a Hummer's velocity? What? Okay, so the momentum for this is part A. Let's do part B. Part B is down here. So for part B, we know that this is the momentum right here. And we want to know, and we also know the mass. So we want to know what the velocity is. So we know this is the formula right here. We know what this is. It's that. We know the mass. It's given to us. It is 2,175 kilograms. So we want to find V. So first thing I'm going to do is I'm going to rearrange this formula to find V. So just divide both sides by m. It's going to be P divided by m equals V. So this is 23200 divided by 2175 equals, what is it going to equal? Well, it equals V, which will equal 10.7 meters per second. And if you double check this, this should make sense that this velocity down here is less than this guy. Whoops. This guy. This guy. This guy up here. Why is it less? Think. It's less because this Hummer has more mass. So to have the same momentum, the same oomph, this car up here has to be going much faster. Okay? All right. Right. So let's do a different problem. Let's do number 2 real quick. That was number 1. This is practice problem number 2. It says a baseball is hit with a force of 1.5 times 10 to the 4th newtons for 0.89 seconds. So we know what the force is. The force is 1.5 times 10 to the 4th newtons. The delta t, change in time, is 0.89 seconds. Great. Baseball's originally going in the negative direction at negative 38 meters per second and has a mass of, so originally was going, the velocity was 38 meters per second, and it had a mass of 0.145. 0.145 kilograms. Great. A. What is a baseball's momentum after being hit? Okay, so what is its momentum after being hit? So we know that impulse equals the change in momentum. The initial momentum was this, and we want to know what the final momentum is. Okay, so we have this, we have that, we have this, and this, and this. All we need to find is u. So let's solve this little equation here for u. Okay, so this is going to be F delta T minus mvf, all divided by negative m. That'll get us u, which is, oh wait, we don't want that. Let's divide this whole thing by negative 1. That will get us mu, which is our initial momentum. So mu is our initial momentum. I could put mu or just initial momentum, but I chose mu. So we want to find what that is. So we've got all these variables over here. So the force is going to be 1.54, 1.5 e to the fourth, minus the mass, which is 0.145, and the velocity is negative 38. Well, I'm really squeezing it in there. And it's all divided by negative 1. And this will get us our initial. Oh, do we want to find the final or the initial? Crap, I did the wrong one. Oh no. We wanted to find the final. Okay, let me go backwards. It's alright, I make mistakes. Okay, so we're going to find out the final, this one right here. So it's going to be this plus the initial equals, and this will be the final. I'll just put PF right there. Okay, so this makes it much more easy. This is 1.54 e to the fourth times the time, which is 0.89, plus the mass times the velocity. The mass is 0.145 times negative 38. Perfect. You should get, as a final answer, with just 2 sig figs. Oh man, just 2 sig figs. You should get 1300 kilograms meters per second. Okay. Whew, that was a long one. Now we want to know what the baseball's velocity is after being hit. Well, we know the momentum. That's great. So if we know the mass, we're in business. And we do know the mass. That's the mass. The mass is right here. So for B, we're sitting pretty. It's going to be P divided by M will equal V. So it's this number divided by the mass. And that's going to be 2 sig figs, 9.0 e to the fourth meters per second. Wow, that's pretty fast. Whoa, that circle is pretty bad. There. Okay. All right, those are the warm-up problems. Good luck on the rest of the problems. 3B, the car one, where it says convert this force into mass and then into pounds. You have to think about what the mass is, and then you have to turn that mass into pounds. You need to look up what the conversion factor is. And I'll give you a hint. I don't know if I included this in the problem, but I do know that I can tell you this. I can say that 1 kilogram equals 2.0. No, it's 2.20462 pounds. Okay, that should help you. Good luck. Let me know if you have any problems along the way.